All right, so welcome to the second part of the data visualization lab. This time we're going to look at time series data. So there's two data sets in this section. The first is one for internet usage, and we're going to look at how to manipulate data that's presented basically at the second level. And the second one is going to be data quality in New York City. So let's get started with the internet usage data set. All right, so we're going to pull in data, and it's called WW usage with capital W's, WWW usage. Okay, and we should definitely go and check it out and see what it is. And it's internet usage by minute. This is, I think, 1996, 1997. Oh no, 1998. That's right. So thinking about that, the internet was a very different place and a very different technology. So we want to make some guesses, or we want to come in thinking about the fact that we're talking about the internet in 1998, where no one had a cell phone that was calling the internet. So keep that in mind. Let's ask for the structure of this data set. So structure of WWW usage. And it says that it's a time series. And time series data is very often presented in a time series format. Note that that is not a data frame. So if we want to use it as a data frame and use it with ggplot, which we do, we need to make our data set into a matrix and then make the matrix into a data frame. Because right now it's a time series. So I'm going to set my variable. I'm going to call it www, and I'm going to say, hey, make yourself a data frame. And usage is going to be as matrix www usage, and use time is going to be time www usage. Okay, so what we're looking at is we're saying, hey, we need this matrix. That is a typo, sorry about that. Okay, so our usage is going to be a matrix of www usage. So we're taking this time series and we're turning it into a flat grid format, just like an Excel format. And our first variable name is going to be the usage, and then the use time, so the moment at which it was called, is going to be the time of www usage. When you call this time on a time series, it knows that what you're asking for is the time in the time series. So I'll go ahead and run that, and I realize that I just called it, I have some typos here, sorry about that, www, and assign it like normal, sorry about that. All right, so we have stored that variable, and now we can visualize this quite directly. We just call ggplot www. Our aesthetic is going to be, as you might have guessed, x is going to be usage time, and y is going to be usage. So they're just variables like we've been using all along. And we'll call a geom line, nice and simple. Run that. Oh, use time, not usage time. Sorry. Run that. And we see that at time 25 seconds, we have a bit of a dip, but it's still pretty consistent here. And at time, like, I don't know what this is, 62.5, so maybe here is like 55, we have this huge dip. All kinds of things could explain that. Obviously, we don't have nearly enough information to talk about what this means. Like, we don't know if this was overnight. We don't know if this was just during the day. We don't know what kind of server it was. We don't know anything, really. But what we do know is that we can see a pretty interesting trend, and we'd want to dive into that more. All right, so that's it for the www data. Now let's go ahead and look at air quality. So this is air quality in New York City. And it's for, I think, like 1973, but I'm not totally sure. So let's question the air quality data set. Pull that in. New York air quality measurements, we can click on this, learn some more about it. Yeah, May to September 1973. Okay. So we are going to pull this in. We're going to call data air quality. And we're going to ask, what's your structure? So what does the structure of the air quality data set look like? And we see something that we should really pay attention to. So we have ozone, solar, wind, and temperature. These are integers. This is a number with a decimal place. Month and day are integers, and that's probably not what we want. But let's try to just like naively see what would happen if we just plotted this. So if we go ggplot air quality, and we pass our aesthetic where x is equal to day and y is equal to temperature, let's say. Nice and simple, and we'll make it a line because the line looked so nice for our internet usage. And that looks crazy. Okay, why does that look crazy? Well, what's going on is that for day 1 occurred 6 times, day 2 occurred 6 times, day 3 occurred 6 times, because each day occurs 6 times in this data set, except for like the 31st, right? That only occurs a couple of times in our data set. This is not a date. This just tells us the day of the week. Now, you're saying, why would anyone ever do this? Trust me, if you work with if you work with dates, you're probably going to accidentally do this. And when you see this crazy graph, you'll be like, oh, right, it's not a date. Just speaking from experience. All right, so we need to go back to what we learned about manipulating data in order to get a new date column that actually has a date. So we are going to make, we're going to call air quality, and we're going to call our variable new date. It's going to be very great. We're going to assign it to this function where we paste together air quality, month, air quality, day, and 1973, right? Because we know that all of these were collected in 1973. We're going to separate it by a dash. Okay. So what this is going to give us is month, day, year, all separated by dashes. This still isn't going to give us a date. This is going to give us just month, day, year as a string. So strings are not dates. They're not ordered in the same way that dates are. R will do something like order it numerically or order it alphabetically, but it won't be ordered as a date. Okay, so we're going to have to do a little bit more. So we have this stored, and we can like glimpse our data set just to see what this looks like so far. Okay, and we have our new date is a string. It says it's a character, and it has all of these dates as we as humans would write them, right? Like so, just like written language dates. So we're going to call air quality new date again, and we're going to assign it to month, day, year. This function actually comes from the LubriDate package, and it's kind of this amazing and magical way to transform human written dates into computer written dates. So we're going to pass it the air quality and new date, and we go ahead and run that. That's fine. It didn't know the time zone because I didn't tell it, so it applied my current time zone, which is New York. So we'll glimpse this and see what we got. And now you see that we have a date that is formatted in a way that the computer wants to read it. Fantastic! So now, if we go here and we go ggplot and we pass it our air quality dataset, we specify the aesthetic where X is our new date and Y is temp, and we give it a line because lines and time series work great since it is a continuous variable going off into the future. And past that. Much better. This is so much more like what we were expecting, right? It's a little bit cooler in May. It starts to increase in June. We get a cold day. It gets a little bit warmer in July with some cooler days. Gets like hot. We got a heat wave in September, and then it goes back down into October. Excellent. Congratulations. That is it. So if you did all three, extra congratulations. If you are inspired by this one and you want to go back and look at the categorical variables, I highly encourage you to check out the chicken weights data set. But now you have the tools necessary to make visualizations in R. Thank you so much, and I look forward to seeing you in the next lab. All right, bye-bye.